This is section 8.3, Introduction to Probability. I really enjoy probability. All right, we need to write a sample space for the following random event. These sample spaces are going to be multiple choice on your homework. So, month of the year is chosen for a marathon. Okay, so think about months of the year. Your sample space, and they'll have the brackets. It'll be like January, February, March. I'm not going to write all these out. April, May, June, July, August, September, October, November, December. And they'll list all the months. Okay. Student is asked how many points she earned on a recent 60-point test. Okay, so you can earn 0 would be the lowest, 1, 2, all the way up to 60 would be the max. So these 3 dots in the middle are called ellipses. It means it includes all the numbers in between. So she would have scored anything from 0 to a 60 on a 60-point test. The management of a construction company must decide whether to go ahead with building a new skyscraper or to cancel it. The 2 possible outcomes would be go ahead or cancel. A produce buyer for juice companies buying apples. He makes choice of either Virginia, New Hampshire, or imported apples. For this contract, he must also choose large or extra large. Write out the sample space, then give the probability of each. So he could have, and I'm just going to use just shorthand, Virginia and large, or they could be Virginia and extra large. They could be New Hampshire and large. They could be New Hampshire and extra large. They could be imported and large, or they could be imported or extra large. Okay, that order doesn't matter as long as you have all the different combinations listed in the sample space. Again, this part is just going to be multiple choice. Now, if you look at all the possible outcomes, we have 1, 2, 3, 4, 5, 6. 6 possible outcomes. So the total are 6 different types of apples. All right, so they want to know what is the probability that the apple that you select is large. Okay, so we have Virginia large, New Hampshire large, and imported large. So there's 3 out of 6, okay, that are large, and that's going to reduce to 1/2. You do have to have a fraction. It does have to be simplified. Okay. The probability that the apples are imported or extra large. So how many are imported? Okay. So if we look at the number of eyes, there's 2 with eyes. Extra large, 1, I put E in. I should put XL. There's 3 out of 6 that would be extra large, but there is an overlap. We don't want to count the ones that are imported and extra large. That's an overlap. We don't want to count that twice. So we're going to subtract out 1. So 2 plus 3 is 5. 5 minus 1 is 4. And that's going to reduce to 2/3. So, and I'm going to write this out, just a little bit further explanation. So 2 out of 6 are imported. So that's the imported that are large and the imported that are extra large. So we're counting those. 3 out of 6 are extra large. So we have Virginia, extra large, New Hampshire, extra large, And then we have imported extra large. When we subtract out the 1, we are subtracting out the overlap. So what's happening is the imported extra large is getting counted twice. I'm going to subtract out one of those. Okay. So the total we have is going to be 4 out of the 6. We're subtracting out the overlap. So just be careful with that. All right, sample space. New patio umbrella. There's a 12-foot and 13-foot model. And it comes in magenta, baby blue, or pink. Really interesting colors. All right. So sample space. It can be 12-foot and magenta. It could be 12-foot and I'm just going to put blue. It could be 12-foot and it could be pink. Pink and magenta are so close. All right. But they could also have a 13-foot umbrella that is magenta. A 13-foot that is blue. And a 13-foot that is pink. And those will be multiple choice. All right, so the probability that he buys a 13-foot baby blue umbrella. So how many 13-foot baby blues do we have? We have 1. Out of, what's the total we have? Total possible choices. It's going to be 6. What's the probability he buys a 12-foot umbrella? Okay, so there's 3 12-foot umbrellas out of 6. And that fraction reduces to 1/2. What's the probability he buys a magenta colored umbrella? So we have 2 that are magenta out of 6, and that reduces to 1/3. Okay. All right. A single fair 6-sided die is rolled. Find the probability of getting a number greater than 4. So on a regular die, you have numbers 1 through 4. So you have a total of 6. Okay. The probability of getting a number greater than 4. So does greater than 4 include 4? No, greater than 4 is the numbers 5 and 6, which are 2 possibilities. So there's a 1 in 3 chance or probability that you roll a number greater than 4. All right, a gentleman wanting to adopt a puppy from an animal shelter. He finds 8 puppies that he likes, a male and female of each puppy of the 4 breeds. So you have a male Rottweiler and they have a female Rottweiler. Then we have a poodle. Okay, so we have a male poodle and a female poodle. And then finally we have a retriever. So we have a male retriever and a female retriever. I feel like I'm missing one. Oh, a pug. Ugh, I hate pugs. All right. We have a male pug and a female pug. All right, so the total possible, they tell us that we have 8 puppies, but I'm just going to go ahead and write it out. The total we have to choose from is 8. This is why I wrote 6. All right. All right. Find the probability that the man chooses a male puppy. So how many are male? 4 out of the total we have to choose from, which is 8. So that's going to be 1/2. So half of the puppies are males. This table gives the number of fatal work injuries categorized by cause from 2019 in a certain country. Okay. Transportation accidents, 3,000. Assaults and violent acts, 763. Find the probability that randomly chosen work fatality has the following cause. Okay. Yeah, the probability is caused by transportation accidents. Okay, so that's going to be 3065. And we're going to need that over the total. So we're going to have to add this column up on my little bitty calculator here. 5910. I'm going to add it one more time. Right? So the total was 5910. So almost 6,000. 3,000 of those were caused from transportation accidents. That's about half. So we're going to take 3065 divided by 5910. And they do want a decimal, and I don't know how many decimal places. I'm going to do 3 decimal places. The block where you put the answer right below it in parentheses, they tell you what to round to. It's in blue. It'll say round to the nearest tenth, hundredth, 1 decimal place, 2 decimal places. But that will tell you what to round to. Maybe 4 decimal places. All right. We have 150 mathematics professors and how they invest their money between stocks, bonds, and CDs. What is the probability that a randomly chosen professor invested in stocks and bonds? Okay, so this is an overlap. So invested in stocks and bonds is right here. That's 78. Okay. Over the total, what was the total? 150. They tell you it's 150, which is really nice. This would be similar to the Venn diagram we did with the 3 circles. Thank goodness they tell us what the total is. All right. 50 again. Oh, this decimal stops. 0.52. So about half of them invest. The following table gives the counts for 3 price categories of 505 stocks and a stock portfolio. Find the probability that a stock in the portfolio is below $50. So how many are below $50? Right. So below 50 is right here. Okay, 0 to 49.99. So that's going to be 162. And the probability that they're below 50 is going to be 162 over the total, which they give us. You could add these up. It should come up to 505. Okay. Let me put that in my little calculator. To me, the decimals give you more information. And again, I'm just going to go to 3 decimal places, watch what they give you or ask for. So that's 32%. Okay. Whereas these other two, 52%, this is 51%. And we said, 3,000 is about half of 6,000. So that seems reasonable. Okay. Oops. I guess that's all we have for section 8.3.